So sometime back, one of the authors in The Economist wrote an article, and he said, "In manufacturing goes digital, third great change is now gathering pace." And what was interesting about this is what he titled that particular one, and that was a third industrial revolution. And as he looked at this thing, he said 3D printing is going to be a big part of that. A lot of excitement came from this, and a lot of discussion and arguments, but certainly a lot of this excitement. And here's why. And if you look at that, it does make sense. I mean, before they were talking about $1 billion type of industry, and now they're talking about $27 billion, $30 billion type of industry. The rapid prototyping stigma that's been attached to 3D printing, thank you GE, for moving this forward, saying we're not just rapid prototyping, but we're making manufacturable products. It was very exciting where this could go, but $30 billion and revolution, that's not much of a revolution. Consider printed circuit boards, if you will. They're reaching almost $75 billion. Nearly ubiquitous, and nobody's saying revolution with that. So I think the question is, what does it mean? Could you take the two industries such as this, such as printed circuit boards and 3D printing, could you bring them together? And if you did, what would you get from that? Maybe take it one step further, the Internet of Things. If you have followed the Internet of Things, it's obviously a ubiquitous concept, but it's also personalized. Does that mean anything to us? I want you to think about this. There's a guy from Accenture, his name is Jack Ramsey, and they went out and did a survey of all CEOs around the world, the big ones, and he said that 90% of the CEOs around the world, that their number one or number two goal is personalization. What does that mean, and how do we tap into that, and how do we press forward? Have you heard the concept from art to part, or maybe from CAD to reality? What about from printed circuit boards to printed circuit structures? And what does that mean? How can you imagine what that would do, and how would we get there? Using your imagination, what can you think of an object-wise that you can make electrically functional as well? So it's not just structurally functional, but it's electrically functional. I'd like to borrow from Archimedes if I can. He said, if you give me a lever and a place to stand, I can move the world. That's the key word, leverage. So take the concept of 3D printing and all that it does right now, but combine it with some existing exceptional precision, number one, but also known manufacturing processes, and then put it on a single tool. Ladies and gentlemen, welcome to Factory in a Tool. And really where we're going with this is what we call direct digital manufacturing. 3D printing may be the majority, but you're going to put micro-dispensing, micro-spraying, micro-milling, digital polishing, pick in place, post-processing, and in situ monitoring. What does that mean? It means close the loop. That's what that means. Close the loop, and it becomes very important. Archimedes, I don't know if you know this, he also did Eureka. I don't have time to tell you why, which means I found it. Let me give you a warning here, though. This is not a toy. And it's not a toy not just because it's expensive, and I've got to tell you, it is expensive. But the precision on this, we're talking 10 nanometers in resolution, 500 nanometers in repeatability, and near 1 micron in accuracy. For those of you who are roboticists, you know what I'm just saying. And for those of you who are not, let me just explain this. If you want repeatable parts, this is one way you do that. Our platforms are not good. You must improve your platform. And it's interesting, so on the same platform, here's where we're really going with this. We can certainly add, subtract, trim, and polish, but it's that post-process as well. My friends, my co-inventors at Novacentrics, they can center using their pulse forge ceramic on plastic, no damage to plastic. You might not care about that, but maybe you care about centering copper on plastic, and you can see where that goes. But close the loop, in situ, post-processing, yes, but feedback. We put a feedback on with full vision where that's going, and if you want, these are SMEMA standard tools. Drop the panels. When you drop the panels, you can put them in a line. You go see us on the floor right now, what you'll see is 5 heads on a single platform. And it does all the things that we're talking about. Punch the button, out comes the circuit. But what's really interesting is their SMEMA standards. Drop the panels, put them in line, put 10 heads per, put 5 of them in there. Now you're going 50 times the speed. Truly, what is the concept of personalization? It is mass customization. What is that? Impossible. That's what they say. And what we're saying is not impossible. It's about throughput, and this is really where we're going. I wish I had time to tell you everything that we've done out there. I don't. I'm going to pick on the phased array antenna, that particular device right there. It is a complex, it's not an antenna, it's a complex set of RF circuitry. And it has all this, and what I want to come to conclusion is one thing, 10x cost savings using this. That's really where we went, 10x cost savings. Pushing a button. Archimedes said, give me a lever and a place to stand, and I can move the world. And I guess we borrow from that, and I say, give me a tool in my imagination, and I can change the world.